So first, the path, okay, and path discovered via pheromone trail. Okay, that's why our formula for pheromone to, sorry, that's why for that's why for pheromone to T plus 1, the formula 1 minus rho to T plus delta 2 T. Okay, the algorithm, the pseudocode first and each end move at random. For our example, TSP, so we put N1 at CTA, for example, N2 CTB, N3 CTC. So we just put randomly. Okay, and then for the movement of N, the N will deposited pheromone on path. Okay, on path. Okay, so how to measure pheromone based on this formula lah. Based on this formula. And then more pheromone on path increase probability of path being followed. So mean the intensity of pheromone. Okay, so the more pheromone, the chances to be used that route. Okay, based on intensity formula, the highest is the best lah. The highest is the best. Okay, and then that's why for this case we using probability formula P. Ingat tak the formula of probability? Yeah, I show you. Panjang nak tulis. Ni. This is the formula of probability ni. Ni. This formula. That's why the pheromone, I mean, for example, from node 1, okay, and then we have more option. We have, for example, we have 4 option. Node 2, node 3, node 4, and node 5. So how to decide or how to determine which node should we choose? Whether A, B, 2, 3, 4, and 5. So we decide through the probability formula P, equation 1. Okay, that the idea how we operate the ACO system. Okay. Okay. I repeat again. Starting node selected at random. Okay, and then path selected at random. For the first iteration lah. Okay, first iteration. Based on amount of trail present on possible path for starting node, higher probability of path is more trail. Okay, and reach each next node, select the next path. How to select the next path using probability formula, and then continues until reach starting node, finish towards a solution. based on iteration lah. For example, if we set iteration 100 iteration, so we need to repeat 100 times. Okay, so for better solution, more receive more trail, mean we have more higher intensity for pheromone for better solution, but the worst solution receive less trail. Less trail mean small pheromone. And then repeat until most and select the same tower on every cycle. Okay, this is the pseudocode for ACO. Okay, this is the pseudocode. Okay, and then okay, I go back. We go back to our example. Okay, so last class we discussed about this example. So I repeat again. Here we have 5 CT. 5 CT and 5 node. CT A B C D E and N 1 2 3 4 5. Okay, then for the CT, the distance between each CT, so we summarize like a table 1. Okay, this is the distance of CTs. Okay, for example, A to B, B to C, and so on. So we put here. So based on the table 1, yeah. Okay, so based on table 1, we calculate the 1/d, the distance, we call visibility of H. So we get the value like this, the table 2, and then the table 3 mean the selected CT for each N1, CTA, and so on. Okay, and then tengok betul-betul and then for the first iteration, we set the pheromone distribution is same. For example, AB, AC, and so on equal to 1, except A to A lah. AA or BB equal to 0 lah, because no distance. Then this is the initial pheromone. Okay, initial state. Okay, phase 1, initial state. So based on this pheromone value, we calculate the P. How to calculate P? Probability P equal to the formula of P like this lah. The formula of P. Okay, like equation 1 ni. Using equation 1. So equation 1, we calculate. So after calculation, for example, A, B, A, C, A, D, and A, E, the P the highest at this route lah, or this path. Okay, so mean this path is the best. So because of AD best compared to AB, AC, and AE, so we using this value to update the pheromone distribution table. How to update? Based on formula to.
Sir, ada orang nak masuk sir.
Oh, okay. Okay, based on the formula to equal to T plus 1 equal to 1 minus rho to T plus delta 2. Okay, so based on AD formula the okay, so delta 2 T plus 1 T plus 1 equal to, so for this case we set rho equal to 0.5. Yeah, this is the constant, the evaporation rate. 1 minus 0.5 to delta T for iteration 1 for AD, okay, AD equal to 1 plus delta T mean delta T equal to, or delta 2 equal to 1 over D plus 1 over 2 sebab A to D equal to 2 kilometers. So equal to 1. So after calculation, so we update AD. So still using the same value. So equal to 1. 1. And then go to the next CT or next N. Okay. For BA, BC, BD, and BE. So BD is the best. BD is the best. So because what the function of P sebenarnya? The function of probability, P. Probability. What the function? The function of probability to calculate or to determine which route is the best. For this case, we're using probability theory, probability formula. So we decide that BC is the best because using the formula of equation 2 probability. Then so we have value like this. So based on this value, we using the equation 2, the pheromone distribution, T plus 1, macam tadi. T plus 1 equal to 1 minus 0.5. Sebab dekat ni, BD, the pheromone value equal to 1 plus 1 over BD berapa BD? Based on the table, BD 2, 2 juga. So 2. So 0.5 plus 0.5 equal to 1. So BD, B to D still have the same value. We update. And then for phase 1, go to the entry pula. Entry using the probability theory, we calculate, then CE is the best. So CE is the best. CE best, then how to calculate, how to update the pheromone distribution table. T plus 1 equal to 1 minus rho T1 to 1 plus delta T. Delta rho to 1 0.5 because delta T to T ni for iteration 1 equal to 1 plus 1 over 4 because CE equal to 4 kilometer kan. So 0.5 plus 0.25 equal to 0.75. So for the CE, the next table, CE, we need to update CE, so 0.75. That one for N3 and number 4. So we have DA, DB, DE, and DC. So based on this, what we call option, we determine the next city or the best road based on using pheromone probability. So the value is the best. This one we're using the first one. Here we have two same value, first and second. So we consider the first one lah. So DA equal to 0.3417 of our probability. So using this value, we consider the distance. So the distance we substitute, okay, based on this formula. So we can get the same value equal to 1 also, DA. So we update here, DA equal to 1 juga. And then for path 5, we calculate using probability. So EA compared to others, EA is the best. So the distance of EA equal to 3. So we using formula distribution pheromone. So T equal to macam tadi lah. T plus 1 equal to 1 minus 0.5 plus 1 over 3. So mean sama dengan 0.5 plus 0.333. So 0.83. So for EA, we update the table ni pheromone 0.83. Now that one for phase 1. And then go back to phase 2, N1. Phase 2, this one, phase 1, phase 2. So we using pheromone again, probability formula to decide or to determine the next city. So the next city is the B, the best. So the distance is 2. So calculate lah macam biasa. Then update the table. And then go to the next city, N2. You calculate, then you update. So after you update, katalah semua you dah calculate, then you update all the not all value lah, yang related value aja you update. Then you use this table as a kat sini. Ni after ni the table ni. The value atas tu you ambil, masuk kat sini. Then based on the value you calculate again the probability formula. You just substitute and then you can get the value like this. So the value ni you tak betul, you kena tukar, you kena calculate balik based on the current, based on the ni lah table ni, updating table ni. Clear? Clear ke tak?
Clear, sir.
Ulang. Siapa yang belum?
Okay,
Ben? Siapa yang belum? And then and then that one for iteration 1, iteration 2, using the current pheromone distribution of the value that we calculate before. So we put here, we change this table lah, the value ni. So we replace. Then based on this value ni, we calculate again, follow the same process till we get the same value for each node. You tengok kat sini. Kat sini. For node, for N1 kan, the total path 16. N2 also 16. Maksudnya dia using the same ni. For each N have same value. Kat sini semuanya 16. For iteration 5. But for iteration 1, you tengok iteration 1. Tengok iteration 1. Iteration 1. Tengok N1 17. After we update the pheromone distribution table, so last we can get the 16, all 16. But N2 16, N3 16, N4 18. So and then So N2 and N4 will change the road. So the final distance for each N equal to 16. So you need to always update the table, pheromone table, then the result, okay, for each N have the same value. Okay, ada siapa tak faham or not so clear?
Clear, sir.
Perlukah clear kan? Okay, so I can summarize like this. For ni, first, first, we set the for initial state, initial phase 1, initial iteration 1. First, we need to decide the number of N, and then the node involved, nodes, okay, and then the parameter involved. For example, the beta value, alpha, the rho, okay, the Q, the K, and so on. The constant, parameter constant, and then second, we need to set the pheromone table. So pheromone table, we set for initial iteration 1, we set have the same, all the value have the same value. For example, maybe we can set 1 or 0.5, 0.5 or 0.5 or equal 1, 1, 1, 1, depend, up to you. Okay, and then third, based on the pheromone table, we calculate the P probability, calculate P. So based on this P, we have the value lah. For example, if we have 10 option, so we have 10 P value. So we choose the best P. Okay, choose the best P. For example, the best P. So based on the best value of P, we refer the distance for that value. Okay, so based on that distance, we using the formula TO the pheromone formula. Formula T plus 1 equal to 1 minus rho multiply T 2 plus delta T, delta 2. So based on the P we refer to distance, the distance of the best P, the distance. So distance we put here. Okay, we replace, and then the distance after that. We update. Okay, after we calculate, so we have value. So the value so we update the table kat sini. So that the ni lah, the summary of ACO. And then that one for N1, N2, you follow the same process, then you update again. N3 also you update, and then till finish. And then after that, you using this table, you you put as a reference for iteration 1 and iteration 2. This one iteration 1. This table you update yang the table ni version 1 version 2 ni. So this table you follow the same calculation. So you update again, update, and then after finish, so the latest version of table pheromone distribution table. So you use for iteration 3 and so on. You need to continue till ni lah you reach the maximum iteration that you set. That's what we call the example of ACO. Okay, I give you 5 minutes or 10 minutes to go through the calculation of ACO. Pukul 9 kita jumpa. Okay, go through. Tak faham, then I explain again.
Okay, sir. the reviews of literature, okay, on safety workers. Mention apa lagi yang you tengok? Okay, surveillance. Surveillances in safety. Let's say you ada tengok on safety industry, so you put in safety industry if you have. Okay, and probably surveillance. Ni example ni surveillance in construction itself. Okay.
Cuma perlu ingat dia punya step dengan formula je.
Okay, so untuk nak ingatkan step, I suggest you calculate the process tu till iteration 6 or 5 or 6. You buat sampai iteration 6 for example, and then you tengok the total distance for each end. Okay, so dari situ you can get the skill lah. You polish your skill. So I think no issue. So you need update the pheromone table tu always. And then based on that pheromone table, you calculate the probability after that. So you need to continuous updating for pheromone table. And then for today, I nak you all siapkan sampai iteration 5 or iteration 6. Then tutorial next week show me the distance for each end. Dapat ke tak dapat untuk the same value, the same distance for each end. I nak tengok. And then next week kita ada tutorial ACO. So I bagi next week lah tutorial ACO soalan. But for today, I nak you all siapkan iteration, number of iteration 5 ni. The calculation. Boleh ke?
InsyaAllah. Boleh cuba sir.
Yeah. So kalau tak ada soalan, we communicate through WhatsApp after this. Okay?
So maksudnya pheromone table tu ke yang kena kira tu yang
Yeah. Pheromone table is very important because based on pheromone table we can calculate the okay, like I give you one more explanation. I repeat again the process. Sekejap. Sekejap. Ya, I buka ni. New slide. Okay. You imagine okay, sekejap. Ada orang nak masuk lagi. You imagine for the first iteration we set the pheromone table. This is pheromone table. Sekejap, ada orang masuk lagi. Okay, ulang. First, we pheromone table. Table. Okay, so we have equation 1, equation 2. Okay, equation 1 for equation 1, P, probability. Equation 2, pheromone. Okay. Okay, first we put N at any city, okay, by random. Okay, so for example, N1, we put, for example, at city A, for example. So we have 10 city, for example, 10 city. So 1, 2, 3, 4, 5, 6, 7 katalah, malah nak tulis 7. So for N1 NA lah kata, NA we put at city, katalah city 6, city 10 lah kata, city 8 katalah, city 8. From 8 to 1 we have 7 option. So how to decide which option is the best for NA ni? So we using apa dia? We using P to decide, using P probability to decide which node to decide node or city for the next city, okay? Decide node, next node. Okay, using P. So the formula of P, okay, formula of P based on apa dia? Ingat tak formula of P? Probability. Tengok balik. Okay, and then for example, katalah we have 1, 2, 3, 4, 5, 6. Okay, 4 is the best. Maksudnya the highest P, highest probability. So the distance between 8 to 4 ni, the distance. So this distance we using to update the pheromone table that we define the first iteration ni. So we update lah. That one for phase 1, for N1. Lepas tu NB pula. NB. So katalah at node 7, kita letak node 7. So from 7 can go to 1, can go to node 2, node 3, 4, node 5, 6, and node 8. Sebab 7 dah ada. So we based on this option, so we using P to determine which the next node, okay? The next node. So maybe the next node P, the 3 is the highest P. So the distance between 7 to 3, the distance, so we're using this value ni, then we replace or we substitute using the pheromone formula. So after we calculate, so we update again the table kat sini. Then till finish for iteration 1. And then after we update ni, so we keep this table. Okay, we keep this table. So we bring to the iteration Iteration 2, we keep this table after you update all the movement. So we using this table for iteration 2. Iteration 2 follow the same process. Boleh faham ke? Boleh kan? Ke tak? Menjawab
Boleh,
soalan
sir.
ke? Menjawab soalan ke tak menjawab soalan yang tanya tadi?
Maksud saya untuk the next week tutorial tu saya nak tengok kami punya table of pheromone tu lah ya.
First, for table untuk next week. First, I nak tengok the latest, maksudnya the table of pheromone for iteration 5. Table of pheromone iteration 5. Iteration 5, and then second, show me the distance. Show the distance for each end. Same or different? Same distance or different? Same or not? For example, for A and N1, maybe 16 kilometers. And B also 16, and C 16. Or ataupun still not reach the same value. Ataupun not. Depend. Then show me the result next week. Clear?
Clear, sir.
So, ni then I bagi tutorial yang soalan yang lain lah nanti untuk next week. So for this week, before we start the tutorial next week, so make sure you try to finish the calculation, the calculation, and please show me the table of it, pheromone table, the latest version, iteration 5, and then the distance for each end. Itu saja for this week. Then next week soalan lain lah. Okay? Yang lain ada soalan?
Sir. Hello?
Ada ke tak?
Tadi ada dengar suara sir, ada orang tanya.
Kalau ada cepat.
Sir, dengar ke? Boleh seterangkan tak yang formula probability tu? Dia tahu darab apa ya?
Okay, jap. Formula probability jap. I need to save. Jap. This is the formula of probability ni. Ni. Ni formula of probability ni. Okay. This formula of probability. Formula of probability tu for ni. You tengok tu ni. For example, you set macam ni. Ni kan? Ni. This is formula of probability ni. Tengok ni. Ni. First, you calculate ni. Sebab yang ni tu ni refer to this table ni. Tu ni. This is the table 2. Pheromone. Tu power of alpha, cos n, and so on. Then, after you substitute this value ni, this one, you substitute to this equation ni, to this equation. So, you can get the P kat sini. Ni the P ni. Ni P ni. Ni. This is P. Ni tu. Ni. Yang ni refer to ni. Ni refer to ni. Ni. The P ni, probability based on this formula. To mean the number of ni lah. The pheromone value kat sini. To. So we set the initial stage equal to 1. Then after that we need to update. So after we update, so the value not like this lah. You need to change the value. Ni lain seperti apa ni. Sebab different. Ni lain, dia cerita ni lain. Sebab dia tak mention row. Row I mention, I set 0.5. But for this case, dia tak mention row. Okay. So after update, you need to calculate again the probability like this, di P ni. So dapat value, the best for P is like this. So you using this distance as a value for delta T, delta tau equal to 1 over D, D equal to 2. So you calculate, then you update, masuk balik dalam table. Okay, menjawab soalan ke? Ke tak? Faham kan?
Saya faham. Cuma macam mana nak dapatkan macam sum of tau darab 1 over distance tu, macam itulah.
Nak to over distance, so that's why the distance tu we refer to the best P kat sini. Kalau kat sini T ni, P ni kat sini distance yang the best. Tujuan P ni, probability ni just to decide which distance is the best. Kalau kat sini kita ada 3, 6, 2 and 3. So the best is 2. Kalau kat lain, contoh yang lain, contoh kat sini. So the best is 3. The best is 2 kat sini. The best is 3. Tengok. The best is 4. Based on the probability formula. So the best distance, so we using the best distance ni for the to calculate the tau T plus 1 ni equal to 1 over minus rho tau plus delta T, delta tau. So delta tau ni yang kita refer to the distance kat sini. Mean delta tau equal to 1 over QK. Q equal to 1 and K equal to distance. So equal to 1 to the distance lah.
Sir, yang total distance tu dia akan balik ke city awal
Total distance.
Dia contohnya N1 path tu kan. A pergi ke D, pergi ke B, pergi ke E, pergi ke C, pergi ke A balik
Ya.
Dia memang macam itulah. Okay. Rasa kalau exam dia keluar soalan macam mana?
Kalau exam tak ada calculation macam ni lah, nanti awak sure tak siap punya. Sebab ambil masa nak calculate ni.
Dia selalunya suruh cari
exam,
apa?
Exam teori lah, teori.
Oh, teori. Okay.
Teori. Kalau calculation for ACO, saya takut you all tak sempat siap. Okay.
Sir, saya ada soalan sir. Untuk setiap N tu kan, dia select macam 4 city tu kan. Jadi untuk setiap city tu dapat probability tu waktu kita update pheromone table. Jadi setiap kali kita pick new city tu, kita akan update table tu lagi
Ya, betul.
Untuk setiap N. Okay.
Betul.
Baik.
That's why you tengok yalah, you tengok example yang dekat dalam table ni. Okay, yang 17 ni kan, 17 ni. After we update ni, katalah kat sini kan, ni after we update ni 17 kan, this for iteration 1. Iteration berapa ni? Ni 17 for N1 masa you tengok dekat iteration 1 17 and then you cuba tengok the last iteration 5 for N1 16, tengok dah berubah dah kat sini, berubah AD BC EA. This one tadi AD, ni AB. Because after you update the table, so the path tu the best path nanti akan ikut sama berubah. Okay, nanti you cuba calculate nanti.
Okay sir, faham.
Sir.
Yang lain?
Sir, saya nak tanya yang individual assignment tu submit bila?
Patutnya submit masa tutorial before you ni, this week kan. Tapi I tengok banyak lagi yang belum submit. Bukan banyak lah, maksudnya ada lagi yang belum submit. So I bagi lagi satu peluang. Mungkin sampai bila you all boleh submit. Sebab nanti I push you tak buat, tak ada guna juga. So I dah bagi kelonggaran ni. Bila you rasa you boleh? Kalau boleh I nak by Friday, this Friday kalau boleh.
Saya rasa last week group A ada bincang answer nak submit 24 hari bulan.
Oh ya, okay.
Yes.
Yang individual kan?
Untuk individual, yes.
Okay, so okay lah kalau, tapi make sure you buat betul-betul tau. Sebab I macam ni lah. I kalau I bagi 24 terus, so nanti you akan delay. So that's why I bagi stages. Maksudnya phase 1, so 1 week before tu you kena submit. Tapi ada lagi yang belum, so that's why ni dah kira dah ada final date lah ni. Tak boleh, lepas ni dah tak boleh terima dah. So kalau boleh you submit this Friday kalau boleh. Kalau tak, so paling lambat before Christmas. This is the last lah. Sebab markah dah nak isi dah ni. Okay?
Okay, sir.
Okay, so kalau tak boleh, kalau tak ada soalan, I think I want to stop here today. So see you next week. Assalamualaikum.
Waalaikumsalam. Thank you,
Thank
sir.
you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.